Alright, welcome to TV Weld. What we're doing today is we're going to do some bend testing. It's a common test that's done to certified welders. We're going to use a 3/8 thick plate groove joint. We're going to use gas metal arc welding. Just a quick little bead progression. We're going to do 1 on our root and 2 over that, so 3 beads total. We're going to do 2 face bends and 2 root bends. So we're going to take strips 1.5 inches wide and we're going to bend them in a jig. Face bend would be bent like this. The root bend would be bent like this. 2 apiece. In order to do a bend test, you have to first pass a visual test. And what I'll do is I'll get the code out and we'll look at the VT criteria and make sure that it passes a VT first. I'll also pull out the bend test criteria so you can see how to actually do the bend test and then also evaluate whether the bend test is acceptable or not. So we'll get out in the lab and we'll get this going.
Alright, this is the visual inspection section out of the D1.1 structural steel welding code. And you can see it's got to be free of cracks. Craters have to be filled to the full cross section of the weld. The face of the weld has to be at least flush with the surface of the base metal. The weld shall merge smoothly with the base metal. Undercut shall not exceed 1/32 of an inch. Weld reinforcement shall not exceed 1/8 of an inch. The root of the weld shall be inspected and there shall be no evidence of cracks, incomplete fusion, or inadequate joint penetration. A concave root surface is allowed within the limits below. The maximum root surface concavity shall be 1/16 of an inch. The maximum melt through shall be 1/8 of an inch. You have to meet all of these standards before you can actually go into a bend test. Alright, this is the face of the weld we just did. You can see it looks pretty good. I'm going to try and get right down on it so you can see that there's nothing on there that'll not make it past a visual. Absolutely no undercut. Now what we'll do is we'll look at how high the convexity is, prove that it's not over 1/8 of an inch. So what we're doing here is we got a caliper and we just extended it out 1/8 of an inch so you can see the convexity requirement. Okay, there you can see it's well under 1/8 of an inch, so we're acceptable on our convexity. Now we're going to take a look at the root. All right, here's our root pass. You can see it's got penetration the whole way down the weld, so we're going to try and zoom in on this again like we did with the face. It's pretty uniform all the way down. There's no lack of penetration, there's no holes or nothing, no lack of fill, there's no suck back of more than 1/32. So we're going to be good to go to our bends here, but we'll check the convexity first. Again, there's our 1/8 of an inch on the caliper. There's our caliper, and you can see it's not even close to 1/8 of an inch. So we're going to go ahead and what we're going to do now is grind the faces off, both the root and the face, and then we'll mark out our bends. We'll cut them, and then we'll bend them, and we'll do some evaluation on the bend. Alright, this is the face, ground nice and smooth. Little tip on your grinding is you want your grind marks to go with the bend. So you want them to go parallel with the bend. That's why they're going across this. If they're going perpendicular, it's a little bit of a stress riser, and you don't want any more stress risers than you need. See if I can zoom in, and there's a zoom in of it. You can see the The line's going across the weld because that's the way it's going to bend. Now we'll take a look at the root. Okay, here's the root. It's ground nice and smooth, except for the tacks, because we're going to cut a 1/2 inch off the weld anyways on the ends. And again, you want to make sure you're going with the bend. See how the marks are going across? So we'll mark this out and get ready to do some bends. Alright, so what we're going to do now is we're going to take this. I'm going to use a mechanical saw, bandsaw, to cut this. It doesn't have enough carbon content in it in order to harden. You got to watch that when you weld stuff. Stuff hardens or fry the blade. I don't like to use cutting methods like plasma and oxy-fuel unless I have to, because you're putting all kinds of heat in here and you're causing distortion in the atomic structure of the metal. So we're going to take this and just cut 1.5 inch strips, and then we'll go over and get our bends done. Alright, now we're taking our strips here, and you can see how sharp of an edge the sides of these bends are. So what we're going to do is get a grinder with a flapper disc on it, or a sander disc, and we're going to make them nice and round, because you don't want them sharp edges because it'll induce cracking. So we'll grab the grinder and I'll show you what I mean by a sanding pad. This is the grinding pad we're going to use. I believe it's 36 grit. And it's just going to sand them edges down, make them nice and smooth so they have a nice transition for when we get into the actual bend. So we're going to sand these down and then we'll be ready to bend. Alright, see how smooth the sides are on this now? Nice and smooth, rounded. Instead of that sharp corner. So now we'll go over the criteria that makes an acceptable bend. Alright, this is the acceptance criteria for bend tests according to the D1.1 Structural Steel Welding Code. The surface shall contain no discontinuities exceeding the following dimensions: 1/8 of an inch measured in any direction, 3/8, the sum of the greatest dimensions of all discontinuities exceeding a 32nd of an inch, but less than or equal to 1/8 of an inch. Corner cracks are a little different. You got 1/4 of an inch is the maximum corner crack, except when the corner crack results from visible slag inclusions or other fusion type discontinuities, then an 1/8 max shall apply. Specimens with corner cracks exceeding 1/4 of an inch with no evidence of slag inclusions or other fusion type discontinuities shall be disregarded, and a replacement test specimen from the original weldment shall be tested, so you can go get another one. You have to meet all these standards in order to pass the bend test. Okay, this is our jig. It's just a press. with that plunger right there. You can see the bend specimens in the middle. The face is down, so that's what we're going to be bending, the face. Alright, here's our 4 bends, and you can tell that we've got massive failure on 3 of them, which if you have massive failure on any of them, you failed the test. Now there's a couple reasons why. First, we're going to look at the brakes, and this just shows you that you can have a perfect looking weld not bend, but it's obvious when you look at the brake why these broke off. So let's take a look at the brakes. Okay, here's the broken piece. We're going to get right in there. See that parting line right there? There was absolutely no fusion there. So basically what you had going on was a great looking weld that didn't fuse all the way through. So you had a line of lack of fusion in the middle of the weld. That's why you do these. This was probably the beginning of the weld where you didn't have the preheat of the weld as it went down the plate, because the last one we bent actually bent and was successful, so it probably preheated it in the beginning to where you got at the end and it was acceptable. But let's take a look at the last bend that actually is going to pass, and we'll take a look at the cracks and determine why it passes. Okay, this is the one bend that would pass. We're going to take it and turn it here. And you can see there's a crack right there on the end. We measured that out to be 0.105 inches, which is not greater than 1/8 of an inch. And by our code, it has to be greater than 1/8 of an inch, or the sum has to add up to 3/8 of an inch. Okay, so the one on the side there is acceptable. The other crack we have is there's a corner crack that measures out to 0.2. And we know, according to our code, that you're allowed to have up to 0.25, quarter of an inch on the corner, unless it's from visible slag, which we're using MIG, so there is none. So this bend is acceptable. So now if you were going to go and retest for this, what you'd want to do is increase your heat, because by looking at all these, why would one pass and the other 3 not? You got to change some of your variables in your welding procedures. Increase your heat. That means turn your wire feed up, turn your voltage up so that it blends in better and you get fusion all the way through your weld. Alright, because we only had one pass, the bend test, we're going to have to weld this, re-bend it, start all over again.
But really what's going on here is the procedure is wrong. We need to have more heat so that that blends in and you have complete fusion throughout the weld. What we need to do is come back, add some more heat. Again, we did this according to our structural steel welding code, D1.1. Thanks for tuning in and subscribing to TV Weld.